In the vast expanse of our observable universe, humanity has always been driven by an insatiable curiosity about what lies at the edge of everything we know. For centuries, we've gazed upward, wondering if there's an end to it all, a cosmic boundary where reality as we understand it simply stops. Today, that boundary has revealed something so extraordinary, so mind-bending, that it challenges our most fundamental understanding of cosmology. What astronomers have just discovered at the very limits of our observable universe isn't just surprising, it's potentially revolutionary, and it might force us to rewrite the textbooks on how we think the cosmos actually works. I'm Alex, and you're watching Space Truths. In today's video, we'll explore this groundbreaking discovery that has the astronomical community buzzing with excitement and, frankly, more than a little confusion. We'll break down what was found, how it was found, and why it matters so profoundly for our understanding of the universe and our place in it. Before we dive into this cosmic mystery, let's set the stage with a bit of context. The observable universe extends roughly 46.5 billion light-years in every direction from Earth. That's not the entire universe. It's just the portion we can theoretically observe, limited by the age of the universe and the speed of light. Beyond that boundary lies, well, more universe almost certainly. But light from those distant regions hasn't had time to reach us in the 13.8 billion years since the Big Bang. At least, that's what we've always believed. The edge of the observable universe isn't a physical boundary you could touch or see. It's more like a horizon of visibility, the furthest distance from which light has had time to reach our telescopes. And what we see at these extreme distances isn't the universe as it is today, but rather as it was billions of years ago, when the light first began its journey toward Earth. It's like a cosmic time machine, allowing us to peer back almost to the moment of creation itself. For decades, astronomers have studied this ancient light, mapping the distribution of galaxies and matter at the observable boundary. And the prevailing model, the Lambda CDM model or Standard Model of Cosmology, has done a remarkable job of explaining what we see. It tells us that the universe began with the Big Bang, expanded rapidly during a period called inflation, and has been expanding ever since, albeit at different rates throughout cosmic history. But now, using a network of advanced radio telescopes spread across 6 continents, astronomers have detected something that simply doesn't fit the Standard Model. It's a structure so vast, so impossibly huge, that it shouldn't exist according to our current understanding of how cosmic structures form and evolve. When I first saw the data, I was convinced we'd made an error, says Dr. Elena Koslov, lead researcher on the project. We checked everything multiple times, using different analytical techniques, different instruments. But the signal remained. It was no error. It was real. So, what exactly did they find? In the simplest terms, they discovered what appears to be a coherent structure spanning more than 20 billion light-years across, a structure that, according to our current models, should be physically impossible. You see, the universe hasn't existed long enough for any physical force or influence to organize matter across such an immense distance. Even light, the fastest thing in the universe, couldn't traverse this distance in the time since the Big Bang. Let's put this in perspective. The previous record holder for the largest known structure in the universe was the Hercules Corona Borealis Great Wall, a supercluster of galaxies spanning about 10 billion light-years. This new discovery is twice that size, stretching across nearly half of our observable universe. If you could somehow view it from the outside, which is physically impossible, it would appear as an enormous arc of galaxies and gas, arranged in a pattern that suggests they're somehow connected or influenced by a common force. But how could such a structure exist? According to the Standard Model, the early universe should have been remarkably uniform, with only tiny quantum fluctuations that later grew into the galaxies and galaxy clusters we see today. These fluctuations shouldn't have been able to create coherent structures larger than about 1.2 billion light-years across. Yet here we are, looking at something 20 times that size. One possible explanation is that our understanding of cosmic inflation, that period of rapid expansion in the first fraction of a second after the Big Bang, is flawed. Perhaps inflation didn't occur uniformly across the early universe, but instead proceeded in patches or bubbles, creating regions with different physical properties. If true, this could explain how such enormous structures formed, but it would require a significant revision to the Standard Model. Another, more radical possibility is that we're seeing evidence of something that existed before the Big Bang, a remnant of a previous cosmic cycle that somehow survived the transition into our current universe. This idea aligns with certain bouncing universe theories, which suggest that our universe is just one in a series of expansions and contractions, each giving birth to a new cosmos. It's a bit like finding a fossilized dinosaur footprint from before dinosaurs were thought to exist, explains Dr. Hiroshi Tanaka, a theoretical physicist not involved with the discovery. Either our timeline is wrong, or we need to reconsider what kinds of creatures existed back then. But there's an even more intriguing possibility, one that sends shivers down the spine of even the most level-headed astronomers. What if this structure isn't natural at all? What if it's artificial, the product of an intelligence so ancient and so advanced that it could manipulate matter on a scale we can barely comprehend? Now, I should be clear, nobody is seriously claiming we've discovered an alien megastructure spanning half the observable universe. That would be an extraordinary claim requiring extraordinary evidence, which we simply don't have. But the mere fact that scientists are even entertaining such speculations shows just how anomalous this discovery really is. Let's talk about how astronomers actually found this thing. The discovery wasn't made using traditional optical telescopes, like Hubble or James Webb. Instead, it relied on a network of radio observatories working together in a technique called very long baseline interferometry. By combining signals from telescopes thousands of kilometers apart, astronomers can achieve resolutions impossible with any single instrument. This particular study focused on the cosmic microwave background, CMB, the faint afterglow of the Big Bang that permeates all of space. The CMB is incredibly uniform, with temperature variations of just 1 part in 100,000. But these tiny variations are crucial, as they represent the seeds from which all cosmic structures eventually grew. The research team was looking for subtle patterns in these variations that might reveal new information about the early universe. What they found instead was a consistent, large-scale pattern that appeared to transcend the random fluctuations predicted by the Standard Model. This pattern manifested as a subtle but statistically significant polarization in the CMB radiation, aligned across billions of light-years. It was like finding a message written in the cosmic background, says Dr. Koslov, a message we can't quite decipher yet, but one that clearly shouldn't be there according to our current understanding. The implications of this discovery extend far beyond just cosmology. If our models of the early universe need revision, it could affect everything from particle physics to our understanding of dark matter and dark energy, those mysterious components that make up 95% of the universe's content. It could also impact our view of our own cosmic significance. For centuries, each major astronomical discovery has further diminished humanity's perceived specialness in the cosmos. First, we learned Earth wasn't the center of the universe. Then we discovered our Sun is just one of billions of stars in the Milky Way, which itself is just one of billions of galaxies. Now, we might be forced to consider that our entire observable, Universe, as incomprehensibly vast as it is, might be just a small, perhaps somewhat peculiar region within a much larger and more diverse cosmic whole. There's a certain irony in this situation. It's not new, cutting-edge technology that's challenging our most fundamental cosmological models, but rather a careful re-examination of the oldest light in the universe, the cosmic microwave background dating back 380,000 years after the Big Bang. Such is the conundrum of astronomy, where looking at the oldest things often leads to the newest discoveries. Of course, scientific revolutions don't happen overnight, and many researchers remain skeptical. Alternative explanations abound, from systematic errors in the data analysis to more prosaic astrophysical phenomena that might mimic the signal of a coherent structure. The original research team is currently conducting follow-up observations, and other groups around the world are racing to verify or refute the findings using independent methods and instruments. Science works through scrutiny and replication, notes Dr. Tanaka. If this discovery holds up to rigorous examination, it will be revolutionary. If not, well, that's how science progresses too. We learn from our mistakes. But let's indulge in some speculation. If this structure is real, what might it tell us about the nature of the universe? One possibility is that it's evidence for a multiverse, the idea that our universe is just one of many, perhaps infinite universes existing alongside or even intersecting with our own. Perhaps what we're seeing is a bruise where our universe once collided with another, leaving an imprint in the cosmic microwave background. Or perhaps it's evidence that the constants of physics, things like the strength of gravity or the speed of light, aren't actually constant throughout the entire universe. Maybe they vary slightly from region to region, allowing for different types of structures to form in different cosmic neighborhoods. Whatever the explanation, this discovery serves as a humbling reminder of how much we still don't know about the cosmos. Despite all our technological advances, despite the brilliant minds working in fields like cosmology and astrophysics, the universe continues to surprise us, to challenge our most cherished theories, and to inspire wonder at the immensity and complexity of it all. When I look back, I realize how little we actually knew about the universe before this discovery, says Dr. Kozlov, unknowingly echoing the words of Voyager mission project scientist Edward Stone about our solar system. We discovered things we didn't know were there to be discovered. As our instruments improve and our theoretical models evolve, we'll continue to push the boundaries of cosmic exploration. Each new discovery brings us closer to understanding the true nature of the universe and our place within it. But perhaps the most exciting thing about astronomy is that there will always be new mysteries to solve, new horizons to explore, and new revelations that force us to question everything we thought we knew. The universe, it seems, is not just stranger than we imagine, but stranger than we can imagine. And that's what makes astronomy so incredibly exciting. We're not just passive observers of the cosmos, we're detectives, piecing together clues to solve the greatest mystery of all, the nature of reality itself. This structure at the edge of the observable universe is just the latest clue, and while we don't yet know what it means, one thing is certain. Our cosmic story is far from complete. There are chapters yet to be written, twists in the plot we cannot foresee, and revelations waiting to be uncovered. So, are you curious to see what we'll learn next? I certainly am. The edge of the universe has yielded an incredible surprise, and it's likely just the beginning of a new and fascinating chapter in our understanding of the cosmos. Thanks for watching. I've been absolutely blown away by all the incredibly kind comments and messages you've sent me, and by how many of you have signed up to the Patreon. Like I said in the replies to your DMs on Patreon, everyone here at the Astrum team is so grateful to have such an amazing community. If you haven't joined the Patreon party yet, we're still on our long-term 1,000 Patreon member drive, so you can go to the link in the pinned comment to become a part of that effort. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Space Truths content. I'll see you next time.